So here we have a diagrammatic comparison to help give an idea of what an IP camera system is. The top diagram illustrates a typical CCTV system where analog video is streamed directly from the CCTV cameras to a central DVR. The digital video recorder converts the analog stream to digital video. Coaxial cable is used for the data delivery, which is only one way. The diagram below illustrates a typical IP camera system. The key difference here is the camera itself is capable of streaming digital video, so there is no need for analog to digital conversion, and the camera is a network device, so the cabling used is usually Ethernet, standard computer network cable. This network connection allows for a two-way communication between users on the network and the cameras. The cameras on the system stream the digital video directly to an NVR, a network video recorder. The main reason why IP camera systems have become so popular is that the cameras can capture and deliver video in much higher resolution than analog to digital systems. There are other benefits to IP video over CCTV, such as using existing network infrastructure. However, higher resolution is the main selling feature. While analog to digital DVR systems will be around for some time, there is fast churn away from CCTV over to IP video, which is reflected in the global camera sales figures. IP camera sales are increasing, while analog camera sales are declining. What's interesting about the two systems is that while one streams analog and the other digital, the topology of both systems are the same. Both the DVR and NVR have a central video surveillance software package installed, which is the core of the system. All the logic resides at this primary computer, which provides the key management functions. So it's actually the nucleus to the entire surveillance system. There's also another IP camera technology available, where all the logic actually resides inside the camera itself. By installing the management software at the camera, the video can be processed at the source, rather than having to transport it to a central NVR for processing. This means the camera actually packages the video as sequences, just like an NVR, and can store the video sequences as ready-to-access files directly to any kind of digital media, hard disk, removable flash, or attached storage. There are many advantages to this. For example, you could direct connect an external Ethernet hard disk drive or attached storage unit and start recording terabytes of megapixel resolution footage at the camera without consuming any network bandwidth at all. Using a standard web browser such as Internet Explorer or a viewing client, users on the network can send video sequence searches based on camera location, event type, time and date to where the video is stored and play these back directly from the storage media itself. As you can see, the only time bandwidth on the common network is consumed is when a query on the stored video is requested by a user. You couldn't do this from a centralized IP camera system such as this because the video has to be processed and packaged by the NVR first. I'll just pause our video here for emphasis because this is important. When all the data streams have to pass through a central point, such as an NVR, it's a bottleneck waiting to happen that can quickly cause network and server overload, especially when you have multiple cameras recording simultaneously in high-resolution video. The more cameras you add, potentially the worse it will get. This is never a problem for decentralized IP camera systems. Thanks for watching. To stay informed as new videos are released, subscribe to the IP Academy channel.